Chapter 5 is on trigonometric identities, and in section 5.1 we're going to be focusing on just the fundamental identities. As your note says, an identity is just an equation that is satisfied by every value in the domain of its variable. So kind of we say an identity is a rule that we hold as being true for any value that we put in for the variable. And now, like I said, this section is fundamental identities. In the box here, you see the reciprocal identities, the quotient identities. I'm going to try to focus in on those a little bit better so we can see. These are basically identities that we have talked about before in the previous chapter. We made reference to these, and these are the ones that you would need to know by memory. Okay, the reciprocal identities, which is cotangent of theta is equal to 1 over tangent of theta. Okay, that's something we've talked about from the beginning. Secant of theta is equal to 1 over the cosine of theta. Cosecant of theta is equal to 1 over the sine of theta. And then we have our quotient identities. The tangent of theta is equal to the sine of theta over the cosine of theta, and the cotangent of theta is equal to cosine of theta over sine of theta. And then we have our three Pythagorean identities. The first one being the basic one, sine squared plus cosine squared is equal to 1. From this one, we can derive the other two Pythagorean identities. Tangent squared plus 1 is equal to secant squared. 1 plus cotangent squared is equal to cosecant squared. Okay, like I said, these are the ones that you should recognize and that you should know from memory. Okay, let's work an example. The first problem here says to find the sine of x if the cosine of x is equal to 4/5 and x is in quadrant 1. Okay, there is, of course, a different way to work this out. We could go back to our definitions in chapter 4 and use those, but what we're showing you here is just a way to use the identities to find your trigonometric functions. Okay, so if I have my problem, I know that the cosine of x is 4/5, then I can use the Pythagorean identity, sine squared of theta plus cosine squared of theta is equal to 1. I actually know this value that I could plug into the equation. So sine squared of theta plus 4/5 squared is equal to 1. And then from here out, it's just algebra. Okay, I would have sine squared of theta plus, if I square 4/5, is going to give me 16 over 25 is equal to 1. Subtract 16 over 25, and we have sine squared of theta is equal to 1 minus 16 over 25. Okay, from here we would have to get a common denominator of 25. So I would have sine squared of theta is equal to 25 over 25 minus 16 over 25. Okay, which that would just be 9 over 25. To solve for the sine of theta, as was asked for in the problem, we would take the square root of both sides at this point. Okay, so this means that the sine of theta is equal to plus or minus the square root of 9/25, which would be 3/5. Okay, we know that it's plus or minus anytime we take a square root, and so at this point we have to determine, is it going to be positive or negative, and that's based on the information in the problem that we're in quadrant 1. So if we're in quadrant 1, all of our trig functions are positive. So our answer would be that the sine of theta is equal to positive 3/5. Okay, now from here, if you were asked to find additional trig functions, it should not be a problem. You could use your identities that are given above, that you have sine and cosine. Then we could find tangent. From that, we could also find cotangent. So just knowing one piece of the puzzle, we can find the other trig functions. Okay, let's look at the next problem. Number 2 says find the cosine of theta if the secant of theta is equal to -7/2. Okay, if we know our reciprocal identities, we know that secant is the reciprocal of cosine, so that means the cosine of theta would just be -2/7. Take your reciprocal, but keep the sign. Okay, number 3, this one's going to be a little bit longer. It says to find the remaining 5 trig functions of theta if the cosecant of theta is equal to -5/2 and theta is an element of quadrant 3. So theta is in quadrant 3. Alright, first thing I'm going to start with is what I know. So we have that the cosecant of theta is equal to -5/2. Okay, well immediately from that, my reciprocal function would be sine. So I could find that the sine of theta would be -2/5. Okay, and then if I want to use my identities to find the other remaining functions, again I would probably go back to the Pythagorean identity. Sine squared of theta plus cosine squared of theta is equal to 1, because now I have the sine of theta that I can substitute into the identity. -2/5 squared plus cosine squared of theta is equal to 1. So that would give me 4/25 plus cosine squared of theta is equal to 1. Subtract 4/25. So we would have cosine squared of theta is equal to 1 minus 4/25. Just like on the problem on the front, common denominator here of 25. So we would have cosine squared of theta equals 25 over 25 minus 4 over 25. So cosine squared of theta is equal to 21 over 25. We have to take the square root of both sides, just as before, to find the cosine of theta is equal to plus or minus the square root of 21 over 25. Okay, again, we are in quadrant 3. Okay, so remember in quadrant 3, is cosine going to be positive or negative? Okay, let me just review for a second. Remember our chart we talked about in chapter 4. They're all positive in quadrant 1. Sine and its reciprocal would be positive in quadrant 2. Tangent and cotangent, and then cosine and secant. So if we're in quadrant 3, this means that tangent is positive, so therefore cosine is going to be negative. So we would have the cosine of theta is equal to negative square root of 21 over 5. We can't break down the square root of 21 any further. So that's one more piece of the puzzle that we're trying to find. From there, since we have cosine, if we wanted to find the secant, it's just going to be the reciprocal. So we could say that the secant of theta would be -5 over the square root of 25. And we never want to leave that radical in the denominator, so I'm going to rationalize. So that would give us -5 square root of 21 over 21. So that would be secant of theta. And then all we have left is tangent and cotangent. Okay, so I'm just going to move over, use one of our quotient identities. Tangent of theta is equal to the sine of theta over the cosine of theta. And so we already know that the sine is -2/5, and the cosine is negative square root of 21 over 5. Okay, complex fraction here, we know that if we're dividing and we have the same denominator, we can divide those out. Two negatives would give us a positive 2 over the square root of 21. Then also we're going to have to rationalize again. So 2 over the square root of 21. Rationalize, we would have 2 square roots of 21 over 21. And that would be the tangent of theta. Okay, then the last one to find would be cotangent. So the cotangent of theta is just going to be the reciprocal of tangent. Okay, or we could look at it, if we use the identity on the front, cotangent is equal to cosine of theta over sine of theta. Well, we could do it that way. And we would have cosine being negative 21 over 5. Sine is negative 2 over 5. Again, these 5s are going to divide out, and we would end up with a positive square root of 21 over 2. So that would be our last trig function that we have to find. Okay, so again, we've done this kind of in chapter 4, but here we're finding the trig function values using our fundamental identities.